All right, time travel with us. We are going to be, that's what I just realized we're doing. We're time traveling. All right, okay. So because we're going to go back in time and we're going to rewrite things and we're going to go forward in time. Um, and just because we're rebasing. Let's see. So, all right. So got the date. It's the most boring time travel you've ever seen. Okay. So all right, so we've got the repo, we've got the date. What else are we supposed to have? The file path. File path. That's a helper, so we'll put it up there. No spell. Set no spell turns off the spell hints. Set spell. This is a Vim, so if you do Vim, so it's escape and then shift and then the semicolon. So escape colon gets you to this, and then you can say set spell. It'll turn on spell hitting, and if you do escape colon again, you do set no spell, it'll turn off spell checking. Okay, so file path to commit file path. This is a prime example of this is sort of like a specific thing, right? So maybe we'll just call it file path, right? So this is it's pretty specific, and this might be a union of stir and pathlib.path. All right. So repo, the date, and the file path. And then one thing came up, resolution strategy. So we're going to, okay, you know, this itself will be a data flow. Um, so, and you will just be able to modify it. So we'll just do a config, or wait, add op, config class. Ooh, oh, I can feel it. It's close. We're close. Okay, where is it? Where is it? Okay. Config class is class data flow or system context. Ooh, where is it? Okay. Ooh. System context config. Op config. System context op config. System context. Okay, config class, system context. I'm like trying to do this fast before I lose it. System context, op config. Okay, I think this is it. So I think we can do, ah ha ha ha. Boop, 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 boop. All right, boop, boop, boop. All right, fantastic. Okay, so, so this is like so easy. It's okay. It's just I feel like I'm failing to see something that should be really obvious to me. Okay. All we want to do is take this. Okay, take this unat. Okay, I want to give you a function. And I'm going to give you a function. Okay. Okay. Return that. Oh, come on. come on. Oh, yeah, okay, it's just a wrapper. Ah, right? Is it just a wrapper? Return op. Turn, I think it's specific, it's a wrapper around functools dot wrap system context op system context. Wait a minute. Op system context. Op system context. Op system context. Op system context. Okay. Okay. Make config. Make config. Okay. I feel like we're close to something. We discovered we was some kind of wrapper. We discovered it was some kind of wrapper. Remember, everything is supposed to be one thing. Everything is supposed to be one thing. So there's like so many things that are the same thing right now. It's all going to become clear eventually. Um, let's look at our example, the base case, right? From within here, we will run a data flow. Okay. Get file, set context. Okay. So could we even do something like this? Op system context. Op system context. Op. Wait a minute. Op system context equals the quest for the most ergonomic API. Okay. System context equals data flow, and then a bunch of other operations, maybe. Or this, perhaps. No. System context op. System context op. Op sc. Op sc. So it's an operation. It takes system context. Man, sorry. Okay. I realize it's probably loud when I breathe into this microphone. Okay. So what just happened and how did this evolve? I had to kind of run with it there for a second. But I think what I realized here was that if we were to take this and put it put it here, all of a sudden we get a this is pretty clean. This is pretty clean. I mean, say what you will, but so this is how we define an output operation. This is how we define an output operation over a given flow. This is how we define an output operation over a given flow. Because then we can take, so this op_sc will then basically just run the system context. Okay, so within func, okay, so wrap. Okay, oh, this is great. Okay, check this out. Okay. Async with self.operations, operation.instance name, ctx, octx as opctx. Okay, so what are we doing here? So this is an A_inter, and a generator can be used with self operations. Call in yield result to run. Okay. 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 So here's what we'll do. So I'll run inputs. So the func. This is, so I was wrong here. So, okay. Because, okay. 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 To do something about. So I think there's something to do with doc not being preserved with functools rep. Double check to see if we need to do anything, or if maybe op already handles it. Do we need to do anything more here? Op just adds properties. Pretty sure. Or I'm not sure about that, so I'm not going to write that. Wrapped. Okay, so we want to take a system context. Actually, we want to support taking either Okay. Op SC. Okay. Op DF. Okay, so we'll have an operation for data flows and an operation for system context. Okay, so what are we doing? We're defining an output method. Yeah, we're defining an output method. Defining an output method. We're defining it. Okay, so the output method is going to come later. So right now what we're doing is we're defining a method call. An output method is just a overlay passed to the op SC. So basically before you do an op SC, if you were doing a data flow on the fly or an overlay on the fly, you would do down here at like 117, you could do this op SC and you could pass it a typed. Oh, I wish we had typed lambdas. I want typed lambdas. Maybe we can do. I want something that is very like language native. Dictionary. Dictionary could work. Dictionary could work, although you don't get the colon syntax. It really would be nice if it was more like a name tuple, but you can't do a class definition there. You can't do a class definition there in that little. You can't do a dynamic class definition, can you? That would look cleaner. I don't like anything that looks like a dictionary or keyword arguments. It doesn't look very clean. For type definition. It's okay. We shouldn't be defining them on the fly anyways. We shouldn't be defining them on the fly anyways. Okay, so getting back to it. Wrapped. Okay. Okay. What time is it? 1. Okay, fantastic. Have we only been going for 3 minutes? Oh, okay. I was like 3 minutes. That doesn't seem right. Okay. More caffeine. All right. So opdf we'll call opsc. Opdf calls opsc sc um, and passes it the system context. The system context config. Does it pass it a system context or does it pass it a system context config? Well, it passes it a system con. It doesn't matter. It doesn't matter because the system context is really just a system context config. There is no like plugin type. It's just a system context config because the system context is the generic construct, which is this sort of like maybe the system context is the open architecture. Or the primary data structure in that. Maybe, but maybe not. Who knows? Right, we'll find out. So, um, okay. Hmm. So this is some kind of lineage that's happening here. So we're going to derive, right? So we need to communicate lineage somehow. So via the parent. So okay. System con or opsc return op class wrapped. Okay. So this function dfmol dfbase. Yeah. All right, let's look at op. This thing is interesting. You see what I mean? Bit of a mess in here. Okay. Implementation context. So we can decorate either a function or a class. Um, when we decorate a function, it creates it creates the class for us. So I think we can do at a minimum providing a implementation context, and then it will create the parent for us. Um, hmm. So implementation, implementation context. Okay. Yeah. Context stacker. Context stacker. Oh yeah, this creates a class that does this interstack, which basically does this context, which is the one in need of a patch, so that you don't have to return a context manager. Okay. So what do we want with this thing? Well, we want imp enter to instantiate the system context. Yeah. Oh, oh, oh. So much better. This is so much better now. Okay, I think this just got infinitely cleaner. Um, so, wait, I lost it. Where was it? What made me think? No, wait, no, what was it? Okay, imp enter. Oh yeah, that's right. Okay, so impinter ctx enter op system context op data flow. And we'll modify, we'll actually just go modify op. Okay. Okay. Alrighty. This is why this is so freaking much logic in this freaking function. It's because we're doing way too many things here. It's like the world's biggest helper function. Okay, so no, I mean it's not it's pretty bad. This is pretty bad. We need to split this thing up. I joke, but it's bad. So let's see. What do we got here? Here we're past the auto definition of imports, or the auto definition of input output, and then we reach the point where we start defining silly test functions. So that's a bad test function. That thing is used several places and it really shouldn't be. It You can see the none. That's bad. This thing's bad. We'll fix it. This is fixing it, I think. Okay, so what are we doing? I think that we can say, where's the args? Or where's the function signature? Signature, self. Okay. Okay. So what about these inputs here? This thing takes args. Why does it take args? Oh, okay. If args. Okay, so this is, yeah, the when it's called with no arguments. Okay, when it's called with one argument. So here, okay, return wrap 0. Okay. Okay, this is where it gets a little, okay, so basically here we're going to say if args, okay. This case handles if op was called with no arguments. Args will be a tuple with one element, that element being func. keyword arguments, not no arguments. Um, let's see. So, all right. So we'll do this and we'll go ahead and say, if arg0 is instance. So okay, so first off, if args is, yeah, if arg0, so if len args is greater than 0 or greater than 1. So if we pass a bunch of stuff, so all right. So if len args, so at op, okay. So let's hypothesize. All right. One, two, three, four. Okay. Return hello. Let's do our hello world example again. Hello entity. Hello. Say hello. Right. So entity. Stir. All right. So say hello is the object of our current attention. So this thing can be given so we can say get entity os.system or os.environ user. All right. So what do we do? We say get entity. Okay, so op get entity. Okay. So we say, hey, we make a suggestion. We say, we suggest you run this operation to satisfy this dependency. This is the suggested mechanism for dependency resolution. Get entity, right? So you need an entity to call say hello. I'm telling you, I have found success calling this get entity function to provide an entity for this function, right? So this is this represents a valid system context. So this is what we've provided to op in this case is we'll basically have op create a data flow and make a system context for that data flow, which defaults to the memory orchestrator and says, hey, if you need an entity, if you need to call this say hello function and you need an entity, go ahead and run this get entity routine. All right. So, and by passing it in here, we set it as the default. So we'll have the default output for a flow. So if you were to say, so say we have a data flow as class, right? And we do a async for, or like system context, right? As sys ctx, right? And then we have system context as ctx, and then we say await ctx, right? So this would be the default, right? So this corresponds to get the default output for a system context, right? So this is no overlays applied, right? So run specific, and then this is run specific overlay on system context output lay for output method. Uh, right? Principles equals context dot strategic principles. All right, so go tell me what is the strategic principles for this context, right? So that requires that there be an operation named strategic principles. So get entity stir. Okay, well, it's going to pick up string there, I think. All right, we might have to do this. All right, that might be the way we have to do it. Okay, so now we've said, so entity equals new type entity stir. Okay, so def get entity returns an entity, and so OS environment user, and then the say hello says for say hello says for the default flow, get the default output for a system context. Suggested compatible operations. So these are suggested compatible operations. So they go within the default. So they go within the default. And is the default a stage? No. Yeah, if you want to run say hello, you need to have some sort of suggestion about what you want to grab the entity value from, right? And so if you don't give me anything, then I'm going to suggest to you this get entity, right? So, and we might have overlays which load, modify the defaults. Okay, we might have overlays which load and modify the defaults, right? So if you say hello, right? So if we say hello Alice, right? Then Alice is going to say hello back to us, but we want to we'll overlay the appropriate source of entity via installed overlays. So when we run the say hello operation, if Alice determines, so if Alice suggests, so if a strategic plan suggests that the say hello operation might be something, is a system context which it submits as a thought, which should be executed within, first it figured, first she hears us and she says, um, so she hears us and we say, hi Alice, and um, so we say, hi Alice, and strategic plan comes in and says, um, response. So two different things happen, right? So one strategic plan says response requested, like somebody's going to want to hear you respond to them within a specific amount of time. You should say something, right? Something that would be appropriate to say when someone says, hi, Alice, right? Depending on the context, right? So then she's going to have other strategic plans that go out, irrespective of the fact that it says you should say something, right? Um, and say it analyzes the parent system context and says, Alice, it would be appropriate if you responded, right? And so I'm going to set a trigger for you with a priority, which says thou shalt respond, aka thou basically, you know, it's just going to do this, right? So if so, async def, uh, you know, phrase heard, we'll just write it. This is the point. Phrase heard. Await async IO dot async def phrase heard. Respond to a phrase, or let's see, phrase heard, check response. Determine, or phrase heard set trigger for response if needed. So we're using a very simple case right now of talking to Alice, but this is also going to translate to like our PR validation when we're doing those, uh, when we're like doing that A/B feature testing where we're cherry picking across branches and um, we need to decide what is pertinent information for the maintainers that are considering merging this branch in terms of how does this data that we're seeing coming in and have seen coming in up until the time where you're deciding to hit merge or not, right? Because we're basically working, if we're thinking that we're Alice right now, we're working with this timeline where you're doing the review, and she's trying to generate as much information for you as she can to help you within the context of that code review, right? And she can't do everything, right? But while from the moment the PR gets submitted, she can start collecting as much information as possible and doing as much, little edits and stuff to make it, to just bring it up to, hey, discover any standards that need to be applied based on the organizational context, right? And then apply them, maybe rework the PR in an automated fashion with the contributor until the maintainer comes in, and then she can tell the maintainer, here's the things that you need to know. But she doesn't know when the maintainer is going to get there, right? So she's going to constantly reprioritize based on what information she's gathering and what scientific processes she's going out, what debugging she's taking to try to figure out, okay, how do I like do as much code review on this thing as I possibly can before the maintainer gets here, right, for this new contributor's PR. And, this is obviously so. Hello world is the very first step in that, right? So we're saying, what do we suggest that she does when someone says, uh, when we need her to say hello, right? But this is the same, once again, it's all the same process, right? So if you say, instead of say hello, it's respond to PR, right? Then what's your suggested flow? Well, my suggested flow with respond to PR, my default flow that we're going to maybe have as part of the default set of DFFML flows that get overlaid, right? So we're going to write an overlay. We're going to install the overlay, and then when we run Alice, she will pick up any installed overlays. She will examine her context that she's running within, and she will, execute within that context as appropriate, right? So each different plugin is going to have different sort of uh, remember it's this adaptive CI, right? And so it's this adaptive context aware CI. And so these overlays are going to allow us to have project specific uh, settings but also facilitate taking these settings across projects and monitoring them in a uniform way so that we can have as much information about our development process as possible, right, to see how our different strategies are playing out when they're applied via these overlays, right? So it's almost like uh, it's almost like we're we're just tracking upstream, right? The our what we're doing here is providing providing a methodology uh, by which we can sort of represent upstream and differences from upstream, and then track divergences and evolutions, as well as performance enhancements or potential like areas for optimization. So it's once again, it's all the same thing, right? So when you have this, then you can go optimize across, and you can do those state of the art, those A/B feature tested branches. Okay. Oh, yeah, I know. I promised time traveling. Okay. So I don't even know what we're. Okay, yeah. I promised time traveling. Okay. May have been a little bit much. Okay. Well, all it is pre-basing. So, um, okay. So this is the default flow. So the default flow. Okay. So phrase heard. Okay. Set trigger response if needed. So what happens on this? So basically, this says phrase heard. This doesn't return anything. response. Decide if a response is needed to a phrase heard. Trigger set trigger for. Okay. Okay. Hmm. Phrase heard set trigger for responses needed. Decide if response is needed to a phrase heard. Okay. All right. So decide. Okay. If phrase dot starts with Alice, return phrase dot starts with Alice. Right. So, okay. Decide response is needed to a phrase. So let's see. Okay. Self.config.name. Let's see. Our entity's name. All right. So self, phrase heard, and our entity's name. All right. So phrase starts with phrase dot lower, starts with our entity's name dot lower. Then we're going to assume that they're talking to us, right? So this is very basic logic. Obviously, this is going to fail on a lot of cases, but it's for the point of illustration, right? So maybe we'll just do this. All right, so if, okay, so I split All right, so I like to do this. So if not phrase split, so this will just, we'll just bail out here. So split the phrase, split the incoming phrase, um, check if we're being addressed. Okay, so this will match things like Alice, comma. All right, and we'll default to Alice. Okay. Phrase split 0 dot starts with, all right, today's name dot lower. Okay. So decided for response. Okay. So example with, okay, speaking to Alice. All right, so, okay, so get entity, say hello. So we can basically take this say hello. How do we do this? So we can take this say hello. We can say, we can decide the top level system context. Basically, when it does a prioritization, it decides which operation to run. So which method to call. And so, or which methods to call, which methods to call. And so, um, so if we say await CTX, it'll do the default. If we say await strategic principles, it'll go run the strategic principles. So if we say Alice, so if Alice is running and she's running in a default flow, which has her listening, right? So she's running in a default flow where she's listening to phrases, right? So let's see, phrase heard. So let's see, right? So phrase heard. So listen for phrases, right? So this is just gonna yield. Okay. Listen for phrases. For phrase in async for phrase in source load source. So async for phrase in load phrase source yield phrase, right? So then we need a phrase source, right? Right, okay, so we need a phrase source. and this is descendant from base source. Is base source a real class? DFML, df source, or source. Yeah, it is base source. Base source, yeah. Okay. So source of phrases is just record dot keys. Phrase dot key. All right. So basically, yeah. So we're loading in these phrases. Well, how are we getting them? They're just record keys. All right. So we can just say async def demo, or let's see, example phrase source, right? And what does this thing do? It returns a phrase source, and that is just really a memory source. And the records in it. Alice, what's up? All right, so we say Alice, what's up? And this listen for phrases says this is the example phrase source, right? So we might have this be like pull requests, right? So this is for the CI/CD case. This is artifacts incoming. This is pull requests. This is whatever, right? This is your arbitrary event source. Okay, so but by default we're saying listen for so example phrase source. Okay, so if you run listen for phrases, okay, phrase heard. Listen for phrases. Okay. So maybe this should be like I hate operator overload. Okay. Okay. Hmm. Playing with how do we suggest for different inputs. So maybe there's an input which is default. Get entity. So maybe this is get entity from env, right? And so then we say, you know, or maybe this is get from env entity. Get from env key. Okay. Stir. Okay. Okay, so we can suggest that because we want to be in the business of suggestion, not of declaration. Don't we don't let's see. So from get from invite. Um, get from invite. Okay, so maybe vars from env. Yeah, maybe to suggest. Oh wait, thank you. Yeah. Are you having lunch or? Oh, you just ate? Okay. Sweet. Thank you. No, that's perfect. Thank you. All right, so we suggest hmm we suggest that when vars from envi is present, let's see, get from envi entity. Envi. I have the get from envi user. Okay. I like this. I like this a lot. So what are we suggesting here? Well, we're suggesting that if you want to get your vars from the environment, right? So if the parent context happens to have this variable laying around, which is vars from envi, then what are we suggesting? No, Thank you to my wonderful wife for the snack. Um, so I think what we're looking at here is the shim. Um, I think we're looking at the shim, and I think we're looking at how we're going to do our A/B testing as well. Um, because this is the default case. For the default case, all right. Hmm. Okay. Hmm. Why don't we have async lambdas? Ah. Oh, that's not Python. I want async lambdas. Closed. All right. So async lambda self. Let's just pretend we had async syntax for a second. We could say, and why is this? We're keeping dependency information with the function, right? So you claim you take a key. This is kind of like the property testing stuff that's in the thread. You claim you take a key. Well, prove it. Give me a default one that works. Give me one functional freaking example, you know? Okay. All right, this is all right. All right. Source space source. I think we need the key value store. All right. I'm trying to figure this out. I think what I'm doing right now is I'm just chaining things up until we figure out where the bottom of this rabbit hole is. Um, we're just doing this full example basically. So the whole thing has to be configurable, right? Because we have to have configurability everywhere. So it's the prove it. We're doing prove it right now. POC. Let's see. Okay. Git. Okay. This is this is interesting. Okay, so we take a key value store, we produce a base key value store context. Okay, so this is actually a plugin, DFML, or what is this? Base. Base configurable. Is it a base configurable? No, it's a base dataflow facilitator object. Okay, so we take a base dataflow facilitator object and we produce a base dataflow facilitator object context. Right, so this is our double context entry. Um, and this will be double context entry, self dot. Okay, big. So this itself, we're gonna wrap this in op2. And this is probably not, so we're playing with this op syntax. Remember, we're always just trying to get a little bit closer to whatever the cleanest syntax is, right? The cleanest way to define it. So config class equals okay. Hmm. Return static config. Okay. Okay. So, okay, so dfml, read dfml base, make config. Okay. Where did we just use that read dfml overlay? No, it's actually in read dfml util CLI. No, internal, because subclass went in here. Or wait, no. Where did subclass go? It went in. Did it go in base? Oh yeah, it went in util CLI. dfml util CLI command. Okay, replace config. Okay. Replace config. Build modifications. Okay. All right. So static config, return self.config.static. At op. config class equals okay. So class static config. Static any. All right. So this static config, right? So this return static config. We'll say static default factory value. How did we do that? Didn't we have a nice little method to, oh, that probably won't help us here. Okay. All right, so op config class. All right. So get from envi static config double context entry get config. Okay. So here's our stuff that's like more application logic down here. All right. I'll be right back. Okay. Okay. So what are we looking at here? Well, so this static config takes static any config class static config return static config double context entry. All right, so we'll write in the double context entry here. Right, so yield CTX. Right, so um, diff, so diff, so basically this, if you need to run this thing and you don't have any other options, then run it with this. So basically, we'll say example. So, okay. Example equals base data flow facilitator object. All right, so basically, if you need to run an example, then here's a base data flow facilitator object for you. Um, you need to run an example. I think we're going to eventually end up with doc strings that actually, that when we'll have some format for the doc strings, which will allow us to write in the doc string basically the things that will are right now being passed to op. And that way we can have our documentation as code. Or our, yeah, we can have our testable documentation for each case. And we'll just split out the cases into these. So like example is here. And then maybe it would say like, hey, here's how you use this with blank, right? And then here's how you use it with variables from the environment. Okay, blank. Here's another data flow, right? So the other possible paths to get here um, in terms of dependency satisfaction. So get from by static config replace config. Statically confined defined config. Um, okay, that looks good. So So we'll probably move these, just double context entry and return static config, and static config will move all this into um, the main package, as well as get from vi. Okay, so return static config example. True. Okay, so this thing doesn't take any. So config class. Yeah, so return static config. Okay, so this thing, you can't use this thing. I don't have any examples for you if you don't have any, let's see. So we don't have any examples for this one. Why don't we have any examples? Well, we could do example instantiations of config. Example. So maybe we could do, yeah, if you have an example, so if you have this example set, so if it's a lambda, so if lambda, do we attempt to run it? When we attempt to run it, we, if given, if op is given a lambda, it should, we don't know the data type. This basically says, trust me. I don't like that. There's no static analysis ability on this, except for via the dynamic analysis. So that's not static because you have to have the trained models. So if I was given a lambda. Okay. How would this look if we wrote it in the doc string? Okay, we're too many levels deep now. Let's pull this out. Okay, wait. Okay, so say hello. Get from and by entity. Right, so if bars from by, get from and by entity. So what that says is within the parent system context, when you run this thing, ah, okay, here's what it says. It says within the parent system context, if you have this variable, okay, within parent system context, if function of I exists as a definition. I wonder if we could use DIDs for definitions. That would be sweet. I bet we could. As a definition, it is for definition. Okay, should get for free if, yeah, we should get that for free by the virtue if we do lineage slash locality via inputs and definitions via input parents. If we switch to lineage slash locality via input parents. Okay. Okay, so when this is great. Okay, so this is great. So we can say, if you see this, I wonder if we could just do, wait a minute, we don't even need a lambda. Forget that. Double context entry, static config, static. Example was static config. Data flow facilitator object. Is this why we did this? Oh, it is why we did this. Oops. Oh, and for key value store, that was it. So double context entry. So default flow says double context entry, or no. So the example flow, says double context entry with static config of base data flow facilitator object. So basically, okay, so call this thing to instantiate this plugin. Okay, so, okay, all this to create object. Okay, so static config, we say call this to create object. I wonder if this needs to be static config. Static config based data flow facilitator object will say, so if we wanted to, okay, so we say static config based data flow facilitator object. Right, so okay. static config. Um, Source okay, wargs. Args. Okay. So basically, so memory key value store. Double context entry. Yeah, if we had lambdas with type hints, this would be so much more convenient. Um, what could we say? We could say, all right, so this is our example. Okay, so git config example. So so here's this type. What do we want here? We want this type. Okay, so this memory key value store, KV store, so base key value store context. So we have to have an understanding that, oh man, okay. We have an understanding that basically memory key value store is a derived type. So base data flow facilitator object context. So memory key value store is derived type. So looking at these return annotations, right? Um, so the double context entry, right, takes this plugin and produces this context, right, the entered context. So we produces the entered context, and okay, so it produces the entered context, and then we want to take that and we want to treat it as a base key value store context within this git config for the example flow. So we're running the example. Maybe we have some console test documentation written. We say use this key value store, maybe via Python API. And now that is going to get populated into op. How? I think we need to take this stuff out of here. Git config. How did we get on git config? Get from or by. Oh yeah, because it was going to be git config. Okay. Okay. So config user. Right, so we need a complete chain of dependencies here. We need a complete chain of dependencies as far as our data goes. That's where we're looking for this chain of provenance here. So um, for the data. So double context entry. Okay. Oh yeah, so let's take this out of here. Oh, that's why this was so confusing. Because we're also, okay, this doesn't matter. Say hello. Okay, we were doing all of this in here. Wow, that's a lot. We were doing a lot in there. Finish after we work on this while we work on entities Alice, Alice, what do we call this one? You know, conversation. Okay, let's grab all this. We're just gonna cat it to the file, right? Then there's our little reminder for ourselves. Let's confirm it's there. Great, it's all there. All right, I'm also actually gonna go and all right. Okay, I'm gonna go ahead and commit all this stuff. Hey, oh, I was just about to stop here. All right. Yeah, I'll see you in like 2 seconds. And then, hey, all right, yeah, we'll talk in a minute. All right. Okay, so let's add this stuff. Work in progress. Get log dash n 1 dash p. All right, okay, so let's take all this stuff. Let's dump it to some patch. We'll roll back one, and then we'll apply it. All right, now we're back where we were. Uh, Now if we take a look at origin manifest, we see it still has that commit on it, which is what is the commit there? We'll save that hash. So work in progress. All right. All right. Okay. Call it for now.